Hi, I'm Stephen Pruitt, President of the Southern Regional Education Board. I'm proud to share something new with you today. At SREB, we are moving into the world of science education because we recognize in the world that we're living in, it's going to be more and more critical that students are able to engage in the phenomena around them and in human design phenomena across all the different aspects of their world. If we really want them to become viable members of our economy and our workforce, the way our workforce is moving, it's going to require more and more science. So, as a former science guy myself, I'm pretty excited about the work that we're doing, and I'd like to share a little bit about it and a first look at what we're taking into account as we're thinking about science instruction. So, I'd like to introduce you to the powerful science instructional practices. Now, this is a framework. This is a way to think about how to cultivate an environment in your classroom that allows students to really engage in three-dimensional performance. Now, hopefully all of you know what those three dimensions are. Science and engineering practices, disciplinary core ideas, and cross-cutting concepts. Now, just to be clear, when we talk about these instructional practices, we're talking about the fact that these are actually practices that teachers and students engage in, not the science and engineering practices. So, let's take a look at what we're talking about and how these can impact your planning and how you may think about going into the science instruction in your classroom. So here we have the wheel. We put everything together, and even though we don't necessarily mean that everything has to go lockstep in this order, it does help in thinking about it. First of all, making sense of natural and human design phenomena. This is the thing that kicks off the unit, that gives the students a real place to go and a real goal to meet. Now, it can be human-made, it can be natural-made. That's why when we talk about phenomena at SREB, we're talking about both. So this is actually a really big, important thing that allows us to think about how students really engage in this instruction. In other words, they're not going to be excited about gas laws. They're not going to be excited about stoichiometry. They're not going to necessarily be excited about ecology and the environment. But if you give them a phenomena that can grab their attention and they know that this is something you're going to come back to during the course of the instruction, then they all of a sudden have something real and tangible that they can attach all their learning to. Developing questions and plan and carry out investigations, design solutions, and or obtain information. Science doesn't do a whole lot of good if we don't know how to ask questions to start with. Now you may say, well, wait a minute, Stephen, that's one of the science and engineering practices. Yep, it is. But the teacher creating an environment where students create their questions and then they're able to pursue those questions is critical to students be able to understand and to be able to pursue these things that they have interest in. So the teacher has to provide that environment. Now, it doesn't mean that you don't teach them. It doesn't mean that you don't scaffold. It doesn't mean that you don't even prompt. But the goal is that students actually create their own questions. Well, why are they going to create their questions? Well, we want them to gather data and information to use in developing evidence. Now, they're going to develop questions, and then they're going to gather data. Now, to be clear, data are numbers. Data are observations. Data doesn't necessarily mean that they have evidence yet, but they are collecting data that could actually help them answer the questions. Well, the next step is that they're going to reason how evidence supports an explanation for the causes of the phenomena. So now they're going to apply reasoning. You see, here's the thing. Data without reasoning is just data. Data with reasoning becomes evidence. And we want our students to not just engage in the data and not just come up with ideas about how that data works. We want them to have the questions that lead to the data that then they apply the reasoning to see how that actually can develop an explanation for that phenomenon. Now, how do we know that? Well, we know it because we want them to engage in scientific discourse. We want them to talk about it. We want them to write about it. We want them to actually debate it among their peers. Because the thing about science is sometimes we think it's a single right answer. But especially as ideas and in particular explanations and arguments are developing, we actually want them to have those conversations. We want them to actually have the argument about whether or not their reasoning applied to that data does answer the question. Now, it doesn't really make much difference if we don't then present evidence of learning. So this is actually where teachers are going to be creating coherent series of three-dimensional performances that still come back to give more information around that initial phenomena. But they create these opportunities for students to engage in the three dimensions to explain other phenomena. And students should be able to, as they do that, they gather more and more data, more and more evidence that supports that initial phenomenon. We want them to communicate that reasoning through individual 3D performances. So it's not enough just to give them a test. We want them to engage in formal and informal three-dimensional assessments. Now, don't get too upset. We're not talking about going and testing everybody. This isn't stop, drop, and test. This is the stuff that good instruction is about. It's about actually providing them more opportunities to have that coherent set of three-dimensional performances and then communicating their reasoning behind what they understood out of that performance. See, here's the thing. These three-dimensional performances, kids should be learning from, as well as giving you evidence of what they know. Well, the last one, and I think maybe the most important one, is to be able to apply science learning beyond the classroom to make sense of natural and human design phenomena. We want students to actually go and find phenomena themselves. We want them to go out and look for it. This is an incredible world we live in. We should let the kids really engage in that and let them come and find that phenomenon and bring it back to class. Now that doesn't happen because a teacher says, all right, gang, we need you to go out and find some phenomena. Good luck, have fun. This is where you're going to have to put it in your classroom. You bring it back and you have the kids bring it in and you have that conversation and then you start this loop over again. Now sometimes they're going to want to do it right then and maybe that doesn't work in your plans and that's fine. But the idea is that the kids go beyond the classroom. Simply staying in the classroom just makes them think that science is just something you learn while you're in that room. We want them to actually understand that science is something you learn all the time and that science ultimately helps you lead to a better career. Now, I'm not going to go through all this, and I know that it's difficult to see on the screen, but as part of our powerful instructional practice, we have created a rubric, if you will, that helps explain a little bit more about what teacher behaviors are in this environment, what student behaviors are in this environment, and what artifacts you may look for to try to find evidence that these things are actually taking place in classrooms. I'm going to show you one. This is the phenomena, making sense of natural and human design phenomena. What's a teacher behavior in this? Well, a teacher behavior is they select and present relevant phenomena that motivate students to make sense and the causes of the phenomena. Now, what that means is this isn't about what motivates the teacher. This is about what motivates the student. It's important that we take into account the cultural backgrounds, the backgrounds that these students have so that we can actually engage them in a way that motivates them, that makes them want to pursue this phenomena to its end to find that explanation. Now, a student behavior is that they carefully observe the phenomena and develop preliminary explanations and solutions. So these are preliminary. So in other words, they're not going to get it right now. But what do they think the explanation for this phenomena might be? And then some artifacts. Well, oral and written preliminary explanations and solutions are actually what we want. We want them to write it down. We want them to even talk about it. Talk about it amongst themselves, talk about it with the teacher. So what you'll see here is that initiating instruction by engaging students in making sense of phenomena is an authentic way to do science. So you want to do it, not have them view it. They want to be involved with it. And then using investigation to engage students in using the science and engineering practices provides the context for student learning. All of this you can find with the powerful science and instructional practice. And you can find this for all 7 of the powerful practices. So here you can go to find the information that you want. We are excited at SREB about giving you the opportunity to engage with us. We're excited about moving into the science instruction, and we're excited about the opportunities that it affords our students, as we know that the world here in the 21st century, and especially in a post-COVID world, that we are more reliant than ever on automation and artificial intelligence that ultimately leads us to the necessity of having a better understanding of how the world works and the thinking processes that go on in science. So thank you for your time. Look forward to seeing you at a future SREB event. And if there's anything that we can do to help support you or your students, please don't hesitate to reach out. Thank you.